Hey guys, what's up? We are going to start now intermolecular forces. That's unit 11. And so prefix here. Let's look at our prefix right there. All right. Um, Intra means within something. Inter means between something. So we were talking about forces between molecules. All right. Like intrastate is a road within a state, like Indiana highways or something. Interstate is a road between states. Sorry, I keep moving myself around to get this. So intramolecular forces in blue, those are attraction between atoms in a compound. So it's like chemical bonds. We're talking covalent bonds and things like that. Ionic bonds, covalent bonds, polar covalent bonds, those are going to be important. Intermolecular forces are attractions between molecules. They hold water molecules close to each other. If you look at the video I did on the board, you'll see it. So intermolecular forces is your attraction between formula units, like molecules. So we have H2O, um, CH4, propane, alcohol, all these different things. Now, between ionic units, this is an ionic interaction. We're going to get into those a little bit later. They're extremely strong. Like think about salt. Like salt doesn't melt, right? It stays as a solid. Um, but these dictate if something will dissolve in water or not. And there's three main types. Vesper is going to be really important. So 3D geometry is going to be, you're going to have to remember it. And we measure their strength by boiling points. So the first is London dispersion forces. These occur in all molecules, not ionic compounds. Oh my goodness, not ionic compounds. These are due to instantaneous dipoles. The electrons are moving around, creating spontaneous spots of positive and negative. All right. And so that's what we have here. All right. And the strength of these is going to increase with molar mass. And I'm going to show you some examples here in a moment. So here, if we look at ethane right here, ethane, the electrons are constantly moving around the structure and they're moving around randomly. So sometimes you're getting a spot that's positive and a spot that's negative. And what you do is get a dipole. A dipole is two poles, positive and negative, and you generate an attractive force. All right. So here you could see um, I have a list of boiling points. All I'm doing is adding a carbon and then the hydrogens that go along with it. These are just straight chain hydrocarbon. And so what we get is methane, negative 162 Celsius, ethane starts to increase, uh, propane, butane, pentane. And you can see that as we start adding more carbons and hydrogens, the boiling points increase. Now, it's not linear in nature. So don't think I add one carbon, it goes up by 5 degrees, another carbon, another 5 degrees. Each molecule is going to be individual in nature. And so this is going right here. As molar mass goes up, so does boiling point. Please remember that. It should be pretty straightforward. It's the primary intermolecular force for non-polar molecules. I think I've made that very clear. All right, so I'm going to finish up here, and then I'm going to do the next two intermolecular forces in the next video.